Yay! We're back to 3D modeling! I'm so sorry for dropping off the face of the earth for 7.5 months or something like that. I'm sorry, life got very busy, work got really busy, everything just got really busy, but that's not an excuse. I should make more videos. So today's episode is going to actually be a response to many comments that I've been getting on the other videos. Sheet metal rules. What are they? How do they work? What's their motivation? We're going to be looking today at sheet metal rules in Fusion 360. So let's jump right in. So today's episode is going to differ a little bit from the usual in that there's a lot less emphasis on the creation of features, using extrusions and revolutions to make geometry. And it's going to more talk about the sheet metal rules that underlie sheet metal design in Fusion 360. So here we have a typical sheet metal component. Well, maybe not so typical, it's pretty useless. But it shows the principle of the thing. We have a bunch of flanges, and importantly, when you create a sheet metal component in Fusion 360, it's possible to create a flat pattern of it so that it's folded out flat, and you can cut it out with a laser, and then you can bend it with a brake press and create your sheet metal part. And that places a lot of responsibility on the sheet metal rules that govern it. So don't commit any of this to memory because we'll be doing some exercise with it a little bit later. But we can see that the sheet metal rule that governs this design is the 5mm steel sheet metal rule. So here we can see that the thickness of the sheet is 5mm, and it's got a particular way of dealing with corner treatments and bend reliefs and bend radii that can all be changed with the rule. If we wanted to change this from a 5mm steel part to a 2mm aluminium part, we might come to the sheet metal rules in the corner, click switch rule, and change it from 5mm steel to 2mm aluminium. Click OK. And now we can see that the rules have changed the geometry. So now it's 2mm thick, the radii are smaller, the way that the corners are treated has changed, the way that the reliefs have changed. So we're going to be playing around with those sheet metal rules in this episode. So let's get to it. We'll start by making a new design. So in the top left corner, click File and say New Design. And we're going to start by making some geometry so that we can actually play with something. So we'll go and we'll say, come to the Sheet Metal tab, click, and then click Create Sketch. And then click the ground plane here. Next, we'll create some simple geometry. We'll start with a 2-point rectangle. Great. Click the origin. And now we're going to draw a 160mm wide by 100mm rectangle. So to do that, we'll type in 160 and then hit tab, hit 100, and then enter. And now I've got a 160 by 100 rectangle. Who doesn't love the golden ratio? We'll click finish sketch. And now we have a closed profile. We're going to create our first base flange. So under sheet metal, we'll click flange. And then we're going to click our closed profile. And for the sheet metal rule, we're going to select one of the rules in our library. Now your library will differ from mine. Don't worry about that. Later, I'll show you how you can add to your Fusion 360 library. So for this exercise, I'm going to choose aluminium 2mm and click OK. Don't worry if you had to select a different rule, the principle's the same. Next, we'll create some flanges to add some geometry to this. So we'll say flange, and we'll pick these two edges to begin with. 1, 2. And then we'll drag them up, and we'll type in 60mm. Wunderbar. Next, we'll go and add another flange on this edge here. So we'll click flange, pick this edge, and we'll go whoop, and we'll type in 60mm. And importantly, we're going to change it from full edge to 2 offsets. And what we can now do is we can drag up this lower arrow and we can make the flange start a little bit higher. So we'll say -20mm. That'll do. Great. And lastly, we're going to go ahead and we're going to add in one more flange. We'll say flange here. And we'll pick this edge and this edge, and we'll drag them in, and we'll make a 20mm long flange there. Great. Okay, so we've got a few flanges here. Lovely. Next, we're going to have a look at changing the sheet metal rule, so to something else that already exists in the library. So to change the sheet metal rule, all we need to do is come to Rule, Aluminium 2mm in the corner, hover over it, and then click the Switch Rule button next to it. And now we'll change the sheet metal rule from Aluminium 2mm to something else in your library. Don't worry about what you select, we're going to be changing it back. Choose something else in the library. So here I might choose Steel 5mm. Here we go, and click OK. And now we can see that the new sheet metal rule is being applied to this existing sheet metal design. Great. Okay, to change it back, we're going to go ahead and we'll go back to Rule, Steel 5mm or whatever you chose in the corner, and then click the Switch Rule button. And we'll change the sheet metal rule back to Aluminium 2mm. And click OK. Great. All right, next we're going to have a look at modifying the sheet metal rules. So to begin with, what we're going to do is we're going to duplicate this existing sheet metal rule, and then we're going to modify that, thus creating our own. So we'll come to Modify, and then click Sheet Metal Rules. In this dialog, we can see all the sheet metal rules that exist locally in this design, and also all the sheet metal rules that exist in your Fusion 360 library. Once again, don't worry if your library is different from mine. I'll show you how to add to this library a little bit later. So let's go ahead and we're going to click Aluminium 2mm. And next to it, we'll see two icons. We'll see Edit Rule and New Rule. Go ahead and click the second. So click New Rule. And here we're going to create a new sheet metal rule. And we're going to call it something for the sake of exercise, so you don't use it in industry by accident. We'll call it my first sheet metal rule. And before exploring these parameters, we'll just go ahead and click Save. And here we can see that we've added my first sheet metal rule to the rules that exist in this design. Now, before continuing, it's very important to note that the rule that's being used by this design is still Aluminium 2mm. So what we're going to have to do is we're going to have to change that rule. So go ahead and click the Close dialog here. And we'll come to the rule that's being used by the design. So Aluminium 2mm. Click the Switch Rule button. And we're going to change the sheet metal rule from Aluminium 2mm to my first sheet metal rule. And click OK. Great. Next, we'll click Modify. And we'll edit the sheet metal rules. And this time, let's go ahead and edit my first sheet metal rule. So select it in the list, click the little pencil. And now we can see all the parameters that underlie this sheet metal rule. So the first one on the list is the thickness. It's the one that we can most obviously see. So what we're going to do is we're going to play around. We're going to monkey around with some of these parameters, and we're going to see how it affects the design. So we're going to be doing a bit of to and fro here. Let's go ahead and start by changing the thickness from 2mm to 4mm. Once you've done that, click Save. And now you'll see that the change in the sheet metal rule is immediately reflected in the design. Now it's twice as thick. Great. We'll edit it again. And this time here we've got K factor. So this is a little bit academic and it's definitely worth looking up. It's a factor that affects how the sheet metal unfolds and folds. So go ahead and for the sake of this exercise, we'll change it to 0.512 and hit Save. And you'll notice that there was no change in the geometry of the design. That's because it doesn't affect the folded geometry, but only how it unfolds. A little bit on that later. We'll go ahead and click the pencil again. And this time we see miter rip seam gap. So what that's referring to is the gap in these bits of geometry. So here we've got a gap in between two flanges, and we've got a little seam here. So let's go ahead and change that. Oh, not that one, a little bit later. Hit the little pencil, and we're going to change the miter rip seam gap. Now you'll notice that at the moment, the gap isn't defined as a fixed number, it's set as a parameter thickness. That thickness parameter is this one here. So at the moment it reads miter rip seam gap is equal to thickness, which is equal to 4 millimeters. So let's go ahead and change that gap from thickness to 0.5 millimeters. And hit save. And you'll notice that the gaps here are now much, much smaller. They're 0.5 millimeter. Fantastic. Excellent. Let's go ahead and change that. So we'll go ahead and we'll say edit the rule. And now, rather than having it as a fixed gap, what we might do is we might change the gap to be thickness times, oh, just leave it as thickness, back to thickness. So it'll read the 4 millimeter thickness of the sheet and hit save. And you can see that the gaps in the miters and the seams are now equal to the thickness of the part, which is 4 millimeters. Great. Okay, next what we're going to have a look at is the bends. So by default, the sheet metal rules in Fusion 360, the bend radius is equal to the thickness of the sheet. Let's go ahead and change that. So we'll go to my first sheet metal rule, click the edit rule button, and we'll come along to bend compensations. And here we can see the bend radius, and we can see it's equal to thickness. Let's go ahead and change that to a large value. So let's go ahead and say thickness times 2. We want the bend radius not equal 4 millimeters, but equal to twice the thickness, so 8 millimeters. So we'll say times 2 and hit save. And now we can see that the bends are much bigger. They're 8 millimeters now. We'll change it to a static value. So we'll hit the pencil again, come to bend conditions, and we'll change the thickness to say 12 millimeters. And now we've got grande bends. Wonderful. Not wonderful. Let's change them back. They're too big. We've made mistakes. Let's click edit rule, and we'll change the bend conditions and edit the bend radius back to thickness and hit save. And now our bends are seen again. Lovely. We'll hit the edit rule button again, and we'll expand our bend conditions. And next we'll have a look at the relief. So here, when we talk about reliefs, what we mean is this little notch that gets cut out if you have a flange that doesn't span the full width of an edge. So at the moment, we can see this gap, and if we change the rule, we'll click edit rule, and we'll come to bend conditions, and here we can see the bend width, and we can change it from thickness to say 0.5 millimeters, hit save, and you'll find that that gap is much, much smaller. But you might find the sheet metal people yelling at you if you make such a small gap, so you have to talk with them first. We'll click edit rule, and we'll change it back to equal the thickness of the sheet metal. I'm just going to copy thickness because we're going to use that a lot. The same parameters, so bend relief depth and remnant, also affect this little relief. What I want to hit save so that we can restore the width of that thickness. And now we'll edit the rule again and come to bend conditions. And I want to draw your attention to this one, relief shape. So at the moment we can see that there's a little square notch that makes up this relief. Let's go ahead and change that. So we can change it from straight to tear or to round. So tear gets rid of the relief width entirely. If you hit save, you'll find that it's literally just tearing the sheet metal there. Let's edit it again and do the cool one. We'll come to bend conditions, and we'll change it to bend relief round. And this is my favorite. If we hit save, it changes it from being a square little notch to being a rounded little notch there. That's really, really good for stress. Fantastic. Okay, next we'll have a look at the corner conditions. So here we've got a corner little relief, corner treatment. So we have two bends here, And where the corners meet, there's a little shape that's cut out. This is to allow it to unfold and also to deal with stress. So let's edit our sheet metal rule. And here, if we come to corner conditions, we can come to bend intersection. And here we can see relief shape, trim to bend. Let's go ahead and we can change that. And as before, we've got a few little relief shapes. Let's go ahead and try square. Hit square and hit save. And you can see that a square is cut out on each of these 3 vertices. If we edit it again, we can change it to my favorite, which is we'll come to the corner conditions, 3 bend intersection, and change the relief shape from square to round. And in my opinion, this one's the best for the stress because it's nice and rounded throughout the thing. Okay, before we go on, we can edit the rule. And here you can change the how much relief is at your intersection. So you might say, so for example, the relief size is thickness times 4 by default. You might change it to thickness times 6, in which case it will make that round a bit larger. Great. Excellent. Now, this last one, there's a little bit of a bug that exists in Fusion 360. Autodesk are aware of it, but as of today, they're still working on it. So where 3 corners meet, you can also change how that corner is treated. So the way that works is this. We can come along to Modify, Sheet Metal Rules, Edit your rule, hit the pencil, come to Corner Conditions, and find 3 bend intersection. And the principle here is exactly the same as with the 2 bend intersection, where you've got round with radius or intersection or full round. Unfortunately, it's not working at the moment, but that's okay because I'll show you a workaround. So at the moment, we've got sharp little edges here. And in this corner, we've got nice and rounded all the way. If you are diehard and you don't want to wait for the bug fix to happen, we can edit it here manually, and I'll show you how. So it's a little bit of a workaround. If you want to skip this section because you're not interested, feel free to, but I'll show you how you can get a nice rounded intersection here at that 3 bend corner. So the first thing that we'll do is we'll come to Modify, and we'll come to Unfold, and we'll click one of these surfaces. And then you can tick Unfold all bends if you want to, or you can just pick the bends manually. I'm going to say Unfold all bends. And here we can see, it's not quite the flat pattern, but we can see the sheet metal laid flat with the bends removed. If we come along here to Create Sketch, what we're going to do is we're going to cut a little circular groove out of this. So we'll create Sketch on this surface here. We'll come to underneath the Create panel, click Project, and click these edges here and here, and click OK. Next, we're going to draw a circle, like so. And now we're going to add in some constraints. So we'll say, make the circle tangential between this edge and there, and that edge and there. And the last bit would be to constrain it so that this point here touches the edge of the circle. So to do that, we'll come to Coincident Constraint, click the circle, click the edge, and there we go. We've got a circle that's bounded by these constraints. We'll click Finish Sketch. We'll say Extrude. So hit Extrude, click that little circle bit there, and we'll say Extent Type to Object, that surface, and click OK. And now we've got our rounding. And if you click Refold Surfaces, ta-da! You've got your rounded 3-corner treatment. Fantastic. Okay, so you've got your sheet metal rule, and happy days, you can come along and you can create your flat pattern and hit this surface here. Now, about K-factors and compensations, if you hit OK for the flat pattern, what the K-factor does is it modifies the length of these materials after the bends, so that when you fold it up, it's the correct shape. As for what the correct values for those K-factors are, it's dependent on material and thickness and the technique that you're using for bending them. So yeah, you might want to consult a manual for those. Okay, let's go ahead. We'll finish that flat pattern. It's important to note that the global sheet metal rules apply to all the flanges of a sheet metal component, but only by default. It's actually possible to override which rules a particular flange uses. So let's go ahead, we're going to edit one of these flanges. So we'll go ahead and edit, say, this one. Edit flange 2. We'll click edit feature. And here, we can, in the feature tree, go ahead and click override rules. And what this lets us do is override the values, the parameters that are specified in our global sheet metal rule. So say, for example, we can come here to say bend override. We can tick on to override the bend radius. And now we can put in our own value. So we might change this from 4 to 6 millimeters and click OK. So just for this flange, just for flange 2, the sheet metal global rule was overridden. We're just going to hit undo and continue. And now I'll show you how to save your sheet metal rule into your library. We'll come along to modify, sheet metal rules. And here we'll expand out in this design and sheet metal rule, my first sheet metal rule, and say that I want to add my first sheet metal rule to my library. To do this, all I'll need to do is right click and say copy to library. There you go. And now we have my first sheet metal rule inside your library. And you don't have to follow along for this part, but if I were to come along and say new design, sheet metal, and choose a rule, you'll find that it's in the library. Happy days. Now, so that's a primer on how sheet metals work in Fusion 360. If you hang around a little bit longer, I'll show you something, a little bit of a life hack. So you might be working in an organization and you'll find that the library, unfortunately, your library of sheet metal rules can't be shared yet among many people. But I'll show you how to get around that rule. So say that, for example, you have a part here and you've created a new rule, my first sheet metal rule, inside the part. And you want other people to have this sheet metal rule because it's a great rule and you really want it to be homogeneous across your company. What you can do is you can share your design. So I might say sheet metal rule template is something that I might call this design. You can share this design with somebody else in your team. They can open up the design. They can then come to sheet metal rules, find the rule in your design, right click, and they can then copy it to their library. You can't see it here because we've already copied it to our library, but they wouldn't have it in theirs. If they right clicked it, they could add it to their library. Life hack. Okay, that's all we have time for today. I hope you learned a little bit about sheet metal rules. There's a lot to sheet metal. It's one of those topics that you think, yeah, I understand how it works. And then you get into the weeds and you're like, oh, there's a lot to this. So I hope you learned something. I'm going to get started with a lot more videos this year. So again, thank you very much for watching. Have a good time modeling and I'll see you in the next one. Bye.